Hello everyone, I'm Akihiro Miyata from Nihon University, Japan. There are many accessibility problems. These can hinder the free movement of impaired people. So, we set our research goal of constructing an accessibility map that satisfies both the accuracy and coverage at low cost. We focus on crowdsourcing approaches that require people to acquire data in the field. There are some crowdsourcing systems that allow people to report accessibility problems. However, existing systems rely on people who have sufficient free time and high motivation. This leads us to propose a crowdsourcing platform for constructing accessibility maps that supports multiple participation modes. This design allows participants to select a suitable participation method depending on their free time and motivation. The first mode, Reporter, is for people who have free time and high motivation. Accessibility problems are manually reported by people with photos, descriptions, and location information. This method is similar to typical existing systems. The second mode, Gaming Reporter, is for people who have free time but with less motivation. This is the game version of Mode 1. In this game, participants collect monsters by taking photos of accessibility problems. Each monster corresponds to an accessibility problem. For example, if the user takes a photo of stairs, a monster with a stairs-shaped path will be obtained. To realize the concept of Mode 2, ResNet 50 based neural network estimates the type of accessibility problems contained in the photo. The third mode, Walker, is for people lacking free time but having high motivation. Accessibility problems are detected by analyzing sensor data obtained from walkers' smartphones. Participants act as follows. At first, they launch the app and put the smartphone in their trouser pocket. Then, they walk for their own purposes, such as commuting and shopping. At the same time, the app records their acceleration, angular velocity, and location information. The last mode, Gaming Walker, is for people lacking free time and with low motivation. This is the game version of Mode 3. Participants are divided into two teams to compete in obtaining a larger area of territory by walking. Accessibility problems are detected by analyzing sensor data obtained from their smartphones. Participants act as follows. At first, participants find an area to be obtained from the map of the game screen. Then, they go to the actual place of the area. After that, they put the smartphone in the trouser pocket and they walk to obtain the area. The app records sensor data in the same way as in Mode 3. Shown here is our neural network model for detecting accessibility problems using sensor data. This model can estimate 7 world types such as steps, stairs, and slope with an F measure of 0.89. Our system generates an accessibility map like shown here, conserving the nature of each data collected using each participation mode. Thank you for your attention.